Yeah, exactly. PEMDAS, right? In other words, it's just order of operations, right? So whenever you guys on the test have a question that just asks you for simplification, this is one of the easier questions on the test. So we should all aim 100% to get these types of questions right. I find in my experience that usually students don't have issues with like this kind of content, but this is a good place for you guys to make a silly mistake. So we want to make sure that we avoid that. So with order operations, like you guys already put in the chat, we want to make sure that we follow PEMDAS. This is our rule that tells us what to do first, second, and third. Now, when we're reviewing this rule, it's important to remember that there's two caveats. With multiplication and division and addition and subtraction, you don't actually follow the order of PEMDAS. You just go from left to right. So if there's both multiplication and division, you just do whichever one comes first from left to right. You don't have to do multiplication first and division second. So that's a common mistake. So for this one, we have multiplication and division. So we're going to just work from left to right. From left to right, the first one we have is multiplication. So I'm going to take care of 1 times 0 first, which just simplifies to 0. And then I have to take care of 3 divided by 3, which simplifies to 1. And then you go from left to right to do the subtraction and the addition. 7 minus 0 is just 7. And then 7 plus 1 gives us our answer, which is choice E, which is 8. Okay, cool. Anybody have questions on that one? Should be super simple. The main thing to take away here and apply to all questions like this is order of operations and the two caveats we reviewed. Okay, so the next one is a little bit of a trickier question. This is similar to many questions on this exam, which kind of have like a little twist to them, or like you have to use a little bit of logical reasoning. So they are giving us this information that they want us to use fractions with a denominator of 17 and a whole number numerator. So that means whole numbers. What does whole numbers mean? Is 3.5 a whole number? No. Is 0 a whole number? Do whole numbers start with 0 or start with 1? So on this test, definitions are important because in the word problems, they're going to say things like whole numbers. So you have to know whole numbers are all natural numbers, including 0, starting with 0. So these are 0, 1, 2, 3, 4, and it goes on and on and on. To review some other kind of terms that they use, they sometimes will say integers in a question. What does that mean to you guys? Is negative 17 an integer? Yes. So integers include negative numbers, 0, and positive numbers. Good. And then sometimes they'll also use the word counting numbers. This makes sense, right? The numbers we count with. So we start counting with 1. So in this case, 0 would not be included. So it's 1 and then up. Yeah, 1, 2, 3, 4, 5. Okay, good. So that's just a basic review of what we can expect. Sometimes they use these terms in questions, so it's important you guys know them. Integer is any number from negative to positive, but nothing fractional, nothing decimal. Okay, cool. So now let's see what they want from us in this question. So they're saying with fractions that have a denominator of 17. So again, language is important, right? So denominator is the bottom of the fraction versus numerator is the top of our fraction. How many are between 1/3 and 2/3? So how would I tackle this? There's a few ways that you can try to tackle this. First of all, as an aside, I usually recommend that students studying for the Hunter test have some fractions memorized, common ones, not the ones that end in over 17, but you guys should know that 1/3 is about 0.333, and you should know that 2/3 is 0.67. But I think in this case, the fastest way to do it is to make them all common denominator. So what do I need to make common denominator? I need to figure out 3 and 17, the common denominator between them. So 17 is a prime number, right? So it's not divisible by anything except 1 in itself. So I know that I have to be higher than 17. So the easiest way to do this is just do 17 times 3, which is 51. So 51 is going to be my common denominator. So now instead of 1/3, I want this to be in terms of 51. So I'm going to multiply 17 over 17. And this is going to be 17 over 51. And then on this side, on this extreme, I have 2/3. And I also want this to be in terms of out of 51. So I'm going to multiply the same thing, 17 by 17. And this gives me 34 out of 51. Okay, so now what's going to happen? Now I have a bunch of numbers in between, right? And I have 18 out of 51, 19, and 20, and 21, and so on and so forth until 34, right? But the question says they want denominator of 17 and a whole number numerator. So what that means is, how do I get this back to 17, right? I have to divide by 3. So in order for my numerator and my denominator to be whole numbers, both of those values have to be divisible by 3. Does that make sense to everybody logically? So what that means is like 18 out of 51 will be good because I can divide it by 3, and this is going to be 6 out of 17. And then the next one that's going to work is the next multiple of 3, which is 21. And then the one after that is going to be 24. And the one after that is going to be 27, and then 30, and then 33. And then the next one will be 36 out of 51, which is too high. That's already outside of our range. So instead of wasting time counting all the numbers, we only want to count the multiples of 3. So that's going to be 1, 2, 3, 4, 5, 6. So there's going to be 6 fractions with a denominator of 17 and a whole number numerator between 1/3 and 2/3. Good? Okay. Now, just as an aside, what if I asked you guys the following question? If I asked you, well, how many numbers are between 34 and 17? Do you guys know how to handle that? So this is not really relevant to this question, but I just want to review it because it's important and it comes up on this test. So let's start with something really easy that we can count, right? What if I asked you how many numbers are between 1 and 5? Right? So in that case, we would just say 1, 2, 3, 4, 5, 5 numbers, right? But notice what happens when we subtract. When you subtract 5 minus 1, you just get 4. But if we want to include both 1 and 5, and we can count, right? And we can do it together, right? 1, 2, 3, 4, 5. We can see that there's 5 numbers. So the rule, whenever they ask you about how many numbers are between a range, if you want to include both of the range, both like the lower and the higher end, you subtract, then you add 1, just for you guys to know. And this will work for any range. But if you ever forget this rule, I encourage you guys to use logical reasoning and practice and try something easy that you can verify for yourself, like 1 and 5 or 1 and 3 or whatever it is. And then use that to create a rule and apply it to whatever they're asking you. And that was just an aside for you guys. Okay, any questions on 52? Or are we good to keep going? All right, so let's keep going. So the next thing is asking us just about a sum. The only difficulty of this question is that we have some various forms, right? We've got a decimal, and then we've got 2 different fractions with 2 different denominator. So I think the easiest thing to do is to add these up first. So 3.5, we can turn that into a mixed number. And 0.75 is just 3/4. So we can make this all in terms of fourths, and then it's really easy to add it. So this becomes 3.5 plus 7/4 plus 3/4. So then this can be 3.5 plus 10 over 4. And then you can either turn this into fourths or you can divide that by 2. So let's say we divide by 2, we're going to have 3.5 plus 5 over 2, which then simplifies to 3 and 6 over 2, or just 3 plus 3, which is 6. Okay, so now the question becomes 15% of 6, which is a much easier question, right? 15% of 6. Okay, so how would you guys do 15% of 6? I think the easiest way to do this is to think about 10%, because 10% is really easy. So 10%, we just have to take our decimal place, go one time to the left. So 10% is going to be 0.6. So right away, I know 15% is going to be greater than 0.6, right? So it can't be B and it can't be A. And 15% is just going to be a little bit greater, right? It's not going to be 6 because that's 100%. And 90 is like way, way, way too high. So you don't even have to figure it out. You know that the answer is C. So a lot of you guys in the chat are saying you would multiply 0.15 times 6. Perfectly okay, perfectly legal. But I also just want you guys to understand, like, start using like shortcuts and tricks in your brain to work with the multiple choice to get to an answer much faster. Because 0.15 times 6 is not crazy math, right? Like you can do this pretty quickly, but you're still opening yourself up to a possible arithmetic mistake. So my goal is for you guys to look at 15% of 6 and know, okay, well, 10% has to be 0.6, right? And none of the other answers can possibly make sense because they're too small and 6 is 100%. So you have to be comfortable with picking C, even without doing that multiplication, because it's going to speed you up. And on this test, it's not about arithmetic. Like they are not looking for students that can do this, right? They know that most of you guys can multiply. It's more like quick problem solving. That's how you really do well on this test. So you have to force your brain to kind of do that. Does that make sense to everybody? Another way to think about it is if you know 10% is 0.6, you know 5% is half that or 0.3, and 0.6 plus 0.3 confirms to 0.9. The other big strategy that I always teach students is try to understand the answer, like try to prove it to yourself in more than one way. So like I can prove this answer to you guys by actually multiplying out, by using estimation, or by using percents like this trick that I showed you where you move the decimal place to the left. If I really wanted to prove it, I could also say, well, 15 out of 100 is X out of 6, right? And we could do it that way too and cross multiply. So you want to prove the correct answer to yourself multiple times when you're checking your work. Okay, so let's keep going. So we have a question like this where it's MH plus MH plus MH, and our answer ends up being TM. And each letter represents a single digit. Different letters represent different digits. And our question, our letter in interest is they want us to know, they want us to tell them what the letter T might represent. Okay, so what we know is that we have a 2-digit number, MH. And when we take MH, right, it's a 2-digit number, and we triple it, right, because it's MH plus MH plus MH. So we take a 2-digit number and we multiply it by 3, we end up still with a 2-digit number, right? So what that means is that this 2-digit number can only be a few things. It can only be numbers up to 30, right? Because like 33 times 3 is going to give us 99, which is still a two-digit number. But higher than that, 34 times 3, that's already going to carry, right? So I'm going to carry that one, and now we're going to end up with a 3-digit number, right? So that's the first thing that I would notice, that I know that my answer has to be less than MH, MH must be less than 34. Now, what that means is that M by itself can only be 1, 2, or 3. And H can be anything, right? From 1 to 9, depending on what M is. But M, we know, can only be 1, 2, or 3. Okay, so now we did the hard part, right? That's the hard part, figuring out that M can only be one of these. So now we think, okay, well, if M was 1, what would happen? So if M was 1, we would have 1H, right? Plus 1H plus 1H. And we would add that all up. Now, M repeats here too, right? So if M was 1, then this has to be 1 as well. So then we think, okay, well, do I know a number that when tripled ends with 1? And I do, right? It could be 7, right? 7 times 3 equals 21. So let's say that this is 17 plus 17 plus 17. This will end up being 1. We carry the 2, and then this ends up being 51. And that works out. So our answer is choice D. Now, you guys might ask me, is this the only option that works out? No, there are other options, right? So let's say that we want M to be 2, right? So we can try that. We can say 2, 2, 2. These are all unknowns, but then this has to end up in 2, right? So then you can say, okay, well, what times 3 is 2? And we know 4 times 3 is 12. Right? So then if this is 2, then this goes up here, 2, 4, 6, and then this would be 7. But notice 7 is not an option. Yeah, 24 plus 24 plus 24 is 72 works. That's exactly what I'm showing. But 7 is not an option. And if we wanted M to be 3, that could work also. So for example, we could say 3, 3, 3, and then T3. So these could all be 1, 1, 1, and then the answer would be 93. So 31 plus 31 plus 31 equals 93 could also work, but notice 9 is also not an option. So you just try 1, 2, 3. In our case, the first one we tried, 1 worked and gave us an answer. And that's all there is to it. But I just wanted to show you guys that other numbers would work also, but nothing, like if there are multiple answers, they're only going to give you 1 in the options. So you don't have to worry about it. And I'm just going to rewrite the work so you guys have it in your notes. Okay. Moving on, we have this equation. So the value got a little bit messed up here, but what they're trying to say is like if A times B, if A symbol B, that's going to tell you B to the A power plus 2AB. That's what they're trying to say. This symbol thing just got messed up a little bit. So basically we just follow the pattern, but you still have to use PEMDAS here. So we're going to follow the pattern with 1 symbol 3 first. So 1 symbol 3. What that means is that we're going to take B, which in our case is 3, and we're going to put it to A power. So 3 to the first power plus 2 times A times B. So we just follow the same pattern, and then we simplify this using the rules of PEMDAS. So 3 to the first power is 3, and then 2 times 1 is 2, times 3 is 6, and this will simplify to 9. And then instead of 2 symbol 1 symbol 3, now this becomes 2 symbol 9, and then we follow the same pattern. So now our B is 9, our A is 2, plus 2 times 2 times 9, and then again, we just simplify. 9 squared gives me 81. 2 times 2 is 4, and 4 times 9 is 36. So 81 plus 36. Again, you don't have to work too hard. I know that you guys are so tempted to just add this up, and it's very easy arithmetic, right? So we can do it. But I also just want to open you guys to the idea that I know my answer has to end in 7. Right? Because 1 plus 6 is 7. And I know that 77 is too little because I'm adding something to 81. So right away, just looking at this, I know B is the answer. I don't have to do the math. Does that make sense? I want you guys to get comfortable kind of doing that. Okay. Next one. So we have when all whole numbers between 100 and 150 are written down, how many times does the digit 4 appear? So very common question. they can obviously not just ask you about digit 4, they can ask you about any digit. So take the explanation that I'm going to give you guys, and in your brain, always realize that the point is not to learn how to do this question. The purpose is to learn how to apply whatever I'm saying here for any question. So when you think about how often a digit can appear, you have to realize that we're dealing with 3-digit numbers, right? So 4 can appear in the ones place or in the tens place, but in this question, it cannot appear in the hundreds place, right? Because we're limited from 100 to 350. So when I think about where the number 4 can appear, I know that 4 can appear in the ones, and I know that 4 can appear in the tens place. So let's start with thinking about how many times the 4 can appear in the ones place. So when we're thinking about the ones place, we're looking at numbers like 104, and then every 10 that's going to repeat, right? So we're going to have 114, 124, 134, 144, 154, and so on and so forth, right? 164, 174, 184, and it's going to keep going until we get to 344. That's going to be our last repetition of 4 in the ones place. So if we think about it, instead of trying to count all of them, we realize that technically we're just going 10, 11, 12, 13, 14, 15, 16, 17, 18, all the way up to 34, right? So we're counting between 10 and 34. So how many numbers are between 10 and 34? Remember, we just reviewed how to do this. 25, good, right? So we subtract and we add 1. So we know that there's going to be 25 times that 4 shows up in the ones place. Okay, but now we have to take care of the tens place, right? So we can start with 140. And at that point, it's going to be 140 and then 141 and then 142, all the way up to 149. So how many numbers between 140 and 149? Yeah, 10, right? So we have 10. Then the same thing is going to happen from 240 to 249. That's going to give me another 10. And then from 340 through 349, which is legal, right? Because we're going up to 350. That's going to give me another 10. So that's a total of 30. And we had 25, and then we have 30, and altogether that's going to give me 55. Now, the only thing that I would tell you guys to think about here is technically we're counting like 344 is counted here, and 244 was counted twice, and 144 was counted twice as well. But it's a little bit of a trick because they're just asking you how many times the digit 4 appears. So technically, like they wanted us to count, this is one time that it's appearing, this is another time that it's appearing. So it's good and okay that we counted it twice. But if they were asking you a different question, you would want to account for not counting twice, and then we would subtract them. Does that make sense? Okay. Who has any questions? How are you guys feeling? Oh, you guys want me to repeat 55? Somebody wants me to repeat 55. Okay, so the first thing about 55 is just realize that this is like a typo. So this is an issue with the question print. This should have said, the question should have said A symbol B is equal to B to the A power plus 2AB. So they're giving you a code, right? So they're saying that A symbol B means that you take the number for B, you raise it to the A power, and then you add 2 times A plus B. So when we see 2 symbol 1, symbol 3, the first thing we try to take care of is what's in parentheses. So the first thing that I would take care of is 1 symbol 3. No, this is a mistake. This is no symbol. It just didn't type correctly. It should have just said A symbol B. So one symbol 3, we just follow the pattern, right? So B in this case is 3. So we take 3 and then we raise it to the A power, which is 1. And then we take 2 and we multiply it by A. Yeah, multiply it by A, which in our case is 1. And then by B, which in our case is 3. So you just follow the code and then you actually have to simplify it, right? So 3 to the first power is just 3, and this simplifies to 6, so we get 9. So now, instead of one symbol 3, we look at our question, we replace this with 9. Now we have 2 symbol 9, and now we follow the new code, right? So now, does that mean 2 is 200 or... Okay, so on the real test, the symbol wouldn't be messed up, and if it would be, the proctor would obviously tell you. And I don't understand Anna's question. How do we know what to do when we see 2AB? Does that mean 2 is 200, or do we multiply? So 2AB is normal notation for multiplying, right? It's like saying X, Y, right? You don't have to put the multiplication sign. It's just common notation to mean multiplication. So 2AB means 2 times A times B. All right, does that clear it up for you guys? This symbol is not a real symbol, does not mean anything. They could have drawn a zebra, they could have drawn 17 stars like this. It's just their way of telling you that when you see that symbol, this is the code that you follow. So the symbol by itself does not mean anything. It's not a real mathematical symbol. They could create any symbol in the whole world. They could literally write A symbol B. They're just telling you to follow the code whenever you see that symbol. That's what the question is testing. It could technically be a number, but that's like really confusing. They probably wouldn't do that because then you guys would get confused between like the numbers that you're actually working with and the symbol. So usually they just pick an arbitrary symbol that doesn't mean anything. Okay. Are we good to move on? Okay, so we're going to move on to the next word problem. So we have Mike and Kate, who are siblings. Mike has as many brothers as sisters, and then Kate has twice as many brothers as sisters. How many girls, counting the children only, are in the family? Okay, so with a question like this, I would use the answer choices to help me figure out the problem. So it's kind of like using guess and check, but it's like a smart way of using guess and check because I'm not just going to use random numbers. I'm going to use numbers that are possible answer choices. So let's start with just choice A, right? So let's say that there are two girls, right? So that means we have Kate, who is a girl, and then we have another girl. And now let's see if based on that, that can be true. So Mike has as many brothers as sisters. So if that's the case, then Mike has two sisters, right? Kate and the second girl. So that means that he has two more brothers. So I'm going to say brother, brother. But then Kate has twice as many brothers as sisters. In that case, Kate is going to have three brothers, but she only has one sister. So the second condition is not true, so I know that A cannot be my answer. So then I'm going to try 3. So let's say we have Kate, a girl, and then we have another girl. So now let's see if that's true. So we have Mike has as many brothers as sisters. So that means Mike would have 1, 2, 3 sisters. That means that he needs to have 1, 2, 3 brothers. So we have another brother. And that means that Kate has 1, 2, 3, 4 brothers. And she has 2 sisters. So 2 sisters, 4 brothers. And she has twice as many brothers as sisters. That's true. So 3 works. So we don't have to go much further. And we can just go on to the next question. So sometimes you get lucky. Usually I recommend like starting on either extreme. So starting with the smallest or starting with the largest answer choice because that can help you like guesstimate. Like if the largest one doesn't work at all, you can pivot to the smallest one or the other way around. But in this case, this is the type of question where you can just move on once we figured out that 3 works. Okay, next word problem, we have Alla and Bala together drink 750 ml of water. Alla drinks 50% more than Bala. How much does Alla drink? Okay, so the way that I would think about this, right, is we have like 3 parts, right? So 50%, 50%, and 50%, right? So if Alla drinks this much, that means Bala drinks this much. Does that make sense? In other words, you should think about it as like a 3-to-2 ratio. So if somebody drinks 50% more than somebody else, it's a 3-to-2 ratio is what you have to think about. So basically you can say, well, 3x plus 2x is going to give me 750 ml. So that means 5x is going to give me 750 ml. And then you can divide both sides by 5. So what's an easy way to do this? I would think about 75 divided by 5, which is 15. So this ends up being 150. And then once you realize that it's 150, we know that, well, one of them drank 150 plus 150, and the other one drank 150 plus 150 plus 150. So somebody drank 300 and somebody drank 450, and that makes sense because together it adds up to 750. And Ala is the one that drinks more, so our answer that we're looking for here is 450. The big thing that usually confuses people is when we think about 50% more, a lot of people think it's a 1-to-2 ratio, but you have to understand that it's actually a 3-to-2 ratio. That's the hard part of this question. Okay. Next word problem, we have Robert has been on the road for 1 hour and 50 minutes. He's been traveling at a constant rate. Okay, so constant rate is always really important. Whenever you guys see constant in a question, I usually think about slope. So far, he's traveled 1/6 of the way of his destination. If he continues at his same rate, he will arrive at his destination at 3:30 p.m. At what time did Robert start? Okay, so who knows the relationship between distance, rate, and time? Yeah, good, right? So distance is equal to rate times time. And we can manipulate this expression, right? So if we know distance, we can also say, well, rate then equals distance over time. And then we can say, well, time equals distance over rate, right? So you don't have to know all 3 of them. They're all equivalent, right? If you know one, you can get to the other one. So I usually recommend that students just memorize one, whichever one you like. So we have that relationship that distance is equal to rate times time. Now we know that in an hour and 50 minutes, he traveled 1/6 of the way there. So 1 hour and 50 minutes got him 1/6 of the destination. So how do I figure out how much time it would take him to travel the full destination? What do I have to do? Yeah, so we multiply by 6, right? Because if I multiply this side by 6, I get 6 out of 6, which is the full destination. So I'm going to multiply this side by 6. So when I do that, I get 6 hours, and then 50 times 6 gives me what? What's 5 times 6? 30. So I get what? I get 6 hours and 300 minutes. And then we convert 300 minutes is actually just 5 hours, right? Because 300 divided by 6 gives me 5 hours. So now we get 6 hours plus 5 hours, which is the same thing as 11 hours. Okay, good. So it's going to take hours to make his full trip. Now, I know that he arrives at 3:30. So what does that mean? When did he have to leave? Yeah, so we have to go back in time for 11 hours, which is going to be 4:30 a.m. Now, for time, you guys should know that every 12 hours, the time is the same, but the AM and the PM is flipped, right? So right now it's 6:41, in 12 hours, it's going to be 6:41 again, but AM. So the reason that I say this is because the fast way to do this is, well, 12 hours ago, it was 3:30 a.m., but I need 11 hours ago. So I go forward one more hour and I get to my answer, which is 4:30 a.m. Does that make sense? So that's a kind of rule of thumb that you guys should have in your head about time. Every 12 hours, the time is the same, but AM and PM is flipped. Okay, so next we have, let's agree to call a number nice if it is not divisible by either 4 or 9. So when you read questions like this, it's really important to pay attention to obviously the words that they are highlighting for you. They're bolding and they're capitalizing not. So not is really important to pay attention to, but words like or and are also extremely important to pay attention to. So in this case, they're not saying divisible by both 4 and 9. They're saying either 4 or 9. Okay, so let's think about numbers that fall into the set. So let's say a number like 15, for example, right? 15 is not divisible by either 4 or 9. Or let's say 3. 3 is a nice number. It's not divisible by 4 and 9. So you just want to have some numbers in your set that you know meet the criteria. And then we're going to look through the answer choices and see if we can prove them wrong. And as long as we can prove them wrong, then we eliminate them. So yeah, when there are questions like this, usually it's pertaining only to integers. So 3 is technically not divisible by 9 because we're going to end up with a fraction. So what they want is like, for example, like 36 or 18. Sorry, 18. No, sorry. These are both not correct because they are both divisible by 4 or 9. So let's look at our answer choices. So for example, if a nice number is multiplied by 3, then the result is nice. So we can think of a number that's a nice number, right? Let's say the number 6. 6 is not divisible by 4 or 9. But if we multiply it by 3, then we get 18. And 18 is not a nice number because it's divisible by 9. Basically, what we're thinking about here is any number that's a multiple of 3, can it be divisible by 4 or 9? And there are plenty of numbers that are divisible by 4 or 9. So this one doesn't work. Next, the product of two nice numbers is always nice. So let's see if we can disprove that. So then we can say 2, which is nice, and 6 is nice, and we get 12, which is not nice, right? Because it's divisible by 12. So D does not work. Then the sum of two nice numbers is always nice. So we can think about these two numbers that I wrote up here, 15 and 3. If we take 15 and 3, that's 18, but 18 is not nice because it's divisible by 9. 5 is added to a nice number. So let's think of a nice number. Let's say 3, right? 3 is a nice number, and then we're going to add 5, but then we get 8, which is not nice because it's divisible by 4. And then by process of elimination, the answer is A. But the reason why the statement is always true is because if we have a nice number, right, which means that it's not divisible by 4 or 9, multiplying that by 5 won't make it divisible by 4 or 9 because 5 is not a factor of either 4 or 9. So logically, it makes sense. Does that make sense? Like it's because 5 is not a multiple of 4 or 9. If we were going to multiply it by 3, right, which is what we did here, this is not necessarily true because 3 fits into 9. So one of those numbers might still be divisible by 9, but by 5, we're kind of safe because it's not divisible by 4 or 9. The same thing would be true if they gave us an option where if we multiply it by 2, that wouldn't really work because 2 goes into 4. Does that make sense logically? So you pretty much guess and check, and then when you get to the answer, uh, you try to justify it with logic and make sure that it makes sense. But when we do guess and check, like you don't do it randomly. Like for example, like the result is nice. I'm trying to disprove it, right? So I'm thinking about like values that are divisible by 4 or 9. So I'm thinking about like 4, 8, 12, 16, 20, 24, and for 9, 18, 27, 36. Like those are the numbers in my head that I'm trying to see if I can make one of these like B, C, D, or E, if I can make it one of these numbers based on the numbers that I can choose. Because if I can easily, then I eliminate that. Does that make sense? So it's about guess and check, but it's about doing it in a directed and logical way. Okay. Next one, they're placing these values V, W, X, Y, and Z on the number line. And the question is, which has the greatest numerical value? So obviously, when we think about a number line, you should know that from left to right, the numbers get bigger, right? So as we go left on the number line, this is our smallest value. As we go right on the number line, this is our greatest value, right? That's just common knowledge about how a number line works. So now we should think about we should use a little bit of estimation and common sense. So if we're multiplying x times y, we're going to end up with some sort of negative number, right? Because I'm multiplying a negative number x by a positive number y. So I know that this is going to give us a negative number. Next one, v divided by x. So I'm going to have -3 divided by a negative fraction. Like we can estimate that that's, let's say, -0.1, right? Just to make our life easier. So what we have is negative, we can drop the negatives, right? Because it's going to be positive. So we have 3 divided by 1/10, which is the same thing as 3 times 10 over 1. Sorry, 1. Um, Sorry, I think I estimated too much. It's not 0.1. I guess we would estimate that it's point. I guess it's closer to the metal, so 0.25. But either way, right? So we're gonna have -3 divided by, let's call it -0.1. So that's gonna give me 3 divided by 1/10, which is the same thing as 3 times 10 over 1. So this should give me about 30. The next one is v squared. So v is -3, so -3 squared, that one's easy, is just 9. And then we have y plus z. So this is also easy, this just gives me 2. And then z minus w is going to give me 1.5 minus approximately, let's say negative, I don't know, let's say like 1.8, 1.9. Either way, this is going to be some positive number, but I don't care about it because there's no way that whatever this is going to be greater than 9 or definitely not going to be greater than 30. So at this point, basically, the answer is 30. And really, we don't care what A is because it's going to be something negative, which is going to be the smallest value. So for a question like this is all about estimation. Okay, we've got a magic square. So a magic square is a square where the sum of entries in any row, column, or diagonal is the same. And they want us to tell them what the value of A is. So basically what that means is x plus 7 plus 3x plus 3, right? Has to equal to 3x plus 3 plus 2x plus 10. Does that make sense? So this way must equal this way, must equal this way, must equal this way, must equal this way, must equal this way. That's what they're saying in this magic square. Does that make sense to everybody? Okay. So this is one way that we can do it. We can set up this equation and then we can try to solve and we can say, well, x plus 3x, that gives me 4x, and then plus 10. And on this side, we get 5x plus 13. And then we can solve, we can subtract 4x from both sides and get 10 is equal to x plus 13. And then we can subtract 13 and then we get x is negative 3. And then we can plug in and see what we end up with, right? So that's one way that we can do that. Another way that you can do it is it's a magic square, right? So what this means is, does the value of x really matter? So let's say that x is 0. So if x is 0, obviously all of this disappears, right? So what happens if x is 0? Well, we've got 10 here, and we've got 3 here. So this way, and we're going to call this some number in the middle, right? Because we have to have a number here. And let's think about the diagonals, right? So the sum of the diagonals must be equal. So we can have 10 plus c plus 7, and that has to equal 3 plus c plus a. So here we have 17 plus c, and here we just have 3 plus c plus a. So the c has to be the same, right? So the only thing that's left is the a, which means that a must be 14. Now that's if x is 0. Then we can think, okay, well, it's a magic square, so x doesn't have to be 0, right? What if we make x 1? Well, if x is 1, then this ends up being 12. And this ends up being 9. This is still our value in the middle. This ends up being 8. So now we can say the same thing. Well, we can say 12 plus c plus 8 has to equal to 9 plus c plus a. 20 plus c has to equal to 9 plus c plus a. And then you end up with the same value. Sorry, this should be 6. And then you end up with the same value because when you subtract 6 from both sides, you get that a should be 14. So when dealing with a magic square, this one's a little bit confusing because they're telling you that any column, diagonal, or row is the same, but the problem is that you can't really use this you can't really add it this way because this box is empty. You don't know what's in here. And you can't add it this way because this box is empty. And you can't use this sum because this box is empty. You can't use this sum because this box is empty. So the only sums that you can actually use are going diagonally because both of the diagonals share that same number in the middle, C. Does that make sense? So because they both share that same number in the middle, and because they all have the same x, you can use that to figure out what this value needs to be. But in all the other cases, there's too many unknowns. So again, since some people are just writing that they're confused, what we did was we said, let's say x is 0, right? If x is 0, then this is what our square looks like. If x is 0, then this value up here is 10. This value up here is 3. This value here is 7. This value is a. And this value we don't know, right? What's in the middle. But what I do know is that 10 plus c plus 7 has to equal 3 plus c plus a. So I know that 17 plus c has to equal 3 plus a plus c. So C is the same in both, right? So what that means is 17 has to equal 3 plus A, and then we figured out, well, that means A has to be 14, right? So this is if X is 0. So, but X doesn't have to be 0, right? This has to be true for any value. You don't understand how the bottom corner one is 3. So I'm plugging in 0 for X. So 3 times 0 plus 3, this ends up being 0 plus 3, and that's how we get 3. Same thing here, 0 plus 7, that's how we get 7. 2 times 0 plus 10 ends up 0 plus 10, that's how we get 10. Now, 0 is just the easiest value to use. This is going to be true no matter what. We don't care what C is because they're not asking us. C is some constant. That's the same in both of them. That's why I can get rid of it in both of them. Because when I subtract C from this side, you subtract C from this side, it disappears. It doesn't change your equation. And this would be true for other values of X. So let's say if X is 1, right? If X is 1, then we get 2 times 1 plus 10. So we get 12 in our cube up here. We get 3 times 1 plus 3. We get 6 in our cube down here. 1 plus 7. This ends up being 8. And then this is still A. And then we do the same thing. We say 12 plus C plus 8 has to equal 6 plus C plus A. 12 plus 8, we get 20 plus C is equal to 6 plus C plus A. Again, the C's are the same, so I can get rid of them. And that means that A is still 14. And you can keep trying this with other values. You can plug in X is 2, X is 1,000,000, X is 1,700. Either way, C doesn't matter because it's just a constant. We subtract it at the end, and A will still remain 14. Does that make sense now? Okay, moving on to the next one, we have Mikey prepared 2 gallons of a beverage that contains tea and lemonade in the ratio of 3 to 1. If he added 1/2 gallon of lemonade to the mixture, what was the ratio of tea to lemonade in the new mixture? Okay, so I know that 3x plus 1x altogether is giving me 2 gallons. Right? Because they told me that he mixed it in this range, and altogether we got we've got 2 gallons. So what this means is 4x is equal to 2 gallons. And if I divide both sides by 4, I understand that x equals 0.5 or half a gallon. So what does that mean? That means that originally I have 1.5 gallons of tea. And then I've got 1/2 gallon of lemonade, right? This is his original proportion. And it makes sense because together it adds up to 2 gallons, which is what the question is telling us. Then the question tells me that he adds 1/2 gallon of lemonade. So I'm going to add one more 1/2 gallon of lemonade. What is the new ratio? So now I've got 2 gallons of I've got 1 gallon of lemonade, right? 1/2 plus 1/2. And I have 1.5 gallons of tea. And the question is, what's the ratio of tea to lemonade? So that's 1.5 to 1, but we don't want to work with fractions, so we can multiply everything by 2 to get rid of the 0.5, and then we get 3 to 2, which is our answer, choice C. Okay. So we're halfway through our webinar. I want everybody to take a minute to stretch. Stretch your legs, get up, jump around if you need to. How are you guys doing? Any questions on what we've covered so far? No? Okay, so in that case, we're just going to keep going. So the next one is number 64. So this is another time question. So we have Anne's watch, which is running 2 minutes per hour too slow. Beth's watch, which is running 1 minute per hour too fast. If both watches were correct at 12 p.m., at 1 p.m., Anne's watch is 2 minutes behind, so she's at 12:58, and Beth's is 1 minute ahead, which is 1:01. They set their watches to the correct time at noon. The next time they met, one of the watches was 1 hour ahead of the other. What was the earliest time this could have happened? Okay, so the way that I would think about it is I would start making a table for myself, right? So we can say this is the start. And then we can think about Anne's watch. And then we can think about Beth's watch. And this will be like, let's say time since Sunday noon, right? That's when they started, Sunday, 12 p.m. Okay, so let's say on Sunday at 12 p.m., we know that both of their times are correct, right? So we're at 12 p.m. and we're at 12 p.m. So next, let's say an hour passed. So now it's Sunday, it's 1 hour later, so it's 1 p.m. So Sunday, 1 p.m. What is Anne's clock at in 1 hour? Somebody tell me in the chat. In 1 hour, what happens? Yeah, good. So Anne's clock is at 12:58, right? Because she's 2 minutes behind. What about Beth's? Yeah, 1:01. Good. Okay, so now let's do this for the next hour. On Sunday at 2 p.m. and then the next hour at Sunday at 3 p.m. and then the next hour, Sunday at 4 p.m. What's going to happen to both of their times? What happens to Anne's in the next hour? Yeah, good. 1:56, right? So an hour passed, but she's 2 minutes behind. And then we're going to be 2:54. Good. And then we're going to be 3:52. Good. And then what about Beth's? What's happening on Beth's side? Yeah, good. So we keep going up 2:02, and then it's going to be 3:03, and then it's going to be 4:04. Okay, so we're not going to do this, right, until we get the same value. That's going to take us forever. But the point of doing something like this is finding a pattern. So that's the key to these kinds of questions. So how do I find a pattern? So I can think about the difference between their times, right? So originally there's no difference. Then we have 3 minutes apart. Then we have 6 minutes apart. Then we've got 9 minutes apart. And then finally, we've got 12 minutes apart. So the pattern lies here that each hour, the time is different by 3 minutes apart every hour. Exactly. So now we can think, well, if it's 3 minutes each hour, how long is that going to take for them to get to be the same again, or to be a full hour apart rather? So 3 minutes per hour, there's 60 minutes in an hour, right? So it's going to take them 20 of these iterations for them to for them to be a full hour apart. Does that make sense? So 3 minutes per hour, but we want them to be 1 hour apart. So instead of 3 minutes, we want them to be 60 minutes apart, right? A full hour. That's going to be times 20 on this side, so in 20 hours. So in 20 hours from Sunday noon, that's when we're going to have an hour apart. So how do we think about 20 hours? So you guys can think about it in terms of either 12 hours or 24 hours. That's the easiest way. So if we think about it in terms of 24 hours, then we started on Sunday at noon, right? 12 p.m. 24 hours from there is going to be Monday, 12 p.m. But we are 4 hours late, so that's going to Monday at 8 a.m., which is, or you could make, well, 12 hours and then add 8, whichever way is easier for you guys. Okay, good. So the next one is telling us to look at the pattern and determine how many more shaded squares than unshaded squares will be in the 100 by 100. So again, we're not going to be drawing 100 by 100, right? This is a tricky problem. So whenever you deal with something tricky, you have to recognize that there's going to be a pattern, right? So there's many squares. So let's start with trying to find a pattern. It's not 24 hours, it's 20 hours, right? But we can look for 24 hours because that's easy to count, right? That's going to be 12 p.m. And then we subtract another 4 hours to get to our answer, which is Monday at 8 a.m. for 20 hours total. Okay, so let's try to look for a pattern, right? So in this small square, there are 3 shaded, 1 unshaded, right? Now the next one, there's 3 shaded, and then there's 1, 2, 3, 4, 5, 6 unshaded. And then here there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 shaded, 1, 2, 3, 4, 5, 6 unshaded. So where do we go from here? So basically what it looks like is so eventually we're going to get to 100 times 100 square, right? In that square, there's going to be 10,000 squares in general. So it would be crazy to add it all up. So we can start looking at an even number, right? Because this is an odd number square, right? 3 by 3, 9. But we're ultimately interested in an even number square, 100 by 100. So we can look at this one and we can look at this one to try to figure out our pattern. So in square 2, there is there are 2 more shaded than unshaded, right? Because there's 3 shaded, there's 1 unshaded. So the difference between them is 2. Now, in the next one, the difference between them is 4. So it looks like that there are as many more shaded squares as rows in the shaded, basically, is the pattern that I'm noticing. So basically, what that means is once we get to the 100 by 100, we would expect 100 more squares that are shaded compared to unshaded. Because it seems like the pattern is the difference is 2 and we're at square number 2. The difference is 4, we're at square number 4. So at 100, our answer would be 100. And 2 is pretty hard to prove to yourself that that's a pattern. So we can like try the next one, like a 6 by 6. That's probably what I would do on the test. And then if that pattern is true, at that point, then I would be sure. Does that make sense? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We can prove it to ourselves. And then we have to think about the shading pattern, which would be like this. I think it would be something like this. And then we can count. And then you would see that the difference is only 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh, yeah, hold on. I messed up the shading. So these 3 would be shaded. 1, 2, 3. And then it would be, we skip 1 and then 1, 4, 5, 6, 7, 8, 9, 10. And then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we have 21 shaded. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 unshaded. And the question is asking us about the difference, right, between shaded and unshaded. How many more shaded and unshaded? So they're asking us difference. So the difference here is 6. This is square number 6, and the difference is 6. And square number 2, the difference was 2, and square number 4, the difference was 4. So that's the pattern. That as the number of the number square that it is in the sequence, that's the difference. So basically the question's about finding the pattern. And when you think about patterns, you should think that the pattern would be the same for all the even number squares. So that's why I only cared about 2, 4, and that's why I didn't draw square 5. I just went straight to square 6, looking for that pattern. And the question they're asking us is about 100, which is also even. So at 100, the difference would be 100. It would be way too crazy to try to draw out the 100 times 100 cube. Does that make sense? So this one I would say is probably one of the trickier questions on the exam. This is probably one that I would skip until later. Just from a strategy point of view, I want you guys to be comfortable with skipping questions. I don't want you to take too much time up on a question like this. And also for a question like this, I want you to anticipate that there's some sort of trick. There has to be a pattern because there's no way the test expects you to draw out 100 times 100 square. So just guess and check. Like for example, I would potentially like just noticing that the difference here is always even in the even numbers, 2 and 4, and odd, it seems like in the odd numbers. I would probably pick an even answer choice, right? So my way of guessing, I would probably eliminate A, C, and E. Does that make sense? Even if I wasn't able to figure out that this is the exact pattern. So just trying to throw in pointers and tips of the way that your brain should think on this test to kind of get the right answer, even if you're not 100% sure. Okay, next one, number 66. We have Lena and her three friends bought enough food so they could all go for a 12-day camping trip. And then Peter and Jane surprised them by showing up, but they brought no food. By what percentage would the time for the trip shorten and if everybody ate their normal daily portions? So let's pretend to make our life easier that we only have to eat one meal a day, right? Just to make it make sense. So let's say we eat one meal a day. So we have Lena and three friends. So we've got four people. They all have to eat one time a day and they're going camping for 12 days, right? So I also have to multiply by 12. So what that means is, let's say they had brought 48 meals. So when Peter and Jane join, now instead of four people, we have six people, right? And this doesn't change, still one meal, still 12 days, but this is constant. We've only got 48 meals. So when we do 48 meals divided by those six people, we end up with 8 days. So what that means is their trip had to be shortened by 4 days. And now the question is by what percent, right? So don't get tricked. Don't get tricked. Don't pick four. Um, Oftentimes I notice that they put the trick answer as choice A, because once you guys get to this point, you're like, four, I solved it. You look right at choice A, it's right there, you pick it, you move on. So always just try to glance back at the question before you pick your final answer. They want a percent. By what percent shorter would it be? Well, it's 8 days instead of 12 days, right? So it's 8 out of 12, which is 66% of the original, or 2/3, right? 66% of the original trip, which is 33.33% shorter. Does that make sense? They're asking by what percent did it shorten? Not what percent is it, which is this, but what percent did it shorten? So it got shorter by 4 days. 4 out of 12 is 33 1/3. Okay, keep going. We have Rory loves chocolate. Okay, how did I go from 66 to 33? So they're asking by what percent would the trip shorten? I was just showing that here, this is how long the new trip is 66% of the old trip, but it's shortened by 33 1/3 because it got 4 days shorter, and 4 out of 12 is 33 1/3. So both of these are like different parts of a whole. It just depends which question they're asking you, right? If they're asking you how much shorter, by what percent shorter is this trip now than originally, the answer would be 66 2/3. But they're asking by what percent did it shorten, which is 33 1/3. Does that make sense? The different, like, just depends on the question they're asking. That's what I was trying to show by writing both of these out. Okay, so we have Rory eating chocolate. In 1 hour, he eats half of any amount of chocolate that he has. His sister Cara decided to keep giving him a bar of chocolate every hour. And the question is, how many chocolate bars had Rory eaten at the end of the second hour? Okay, so we can just think about this logically, right? So he has one chocolate bar, right? And after 1 hour, he ate half of it, right? So he has half left. And then somebody gave him a whole new chocolate bar. And in the next hour, he ate half of all the chocolate he had left. So that's going to be like this much. So here he ate half a chocolate bar, right? One half. Now the new amount that he had at this point is 3/2 of a chocolate bar. And here he ate, which is the same thing as 6/4, and here he ate 3/4, right? Half of that. So in total, he ate 1/2 plus 3/4, which is 1 1/4 chocolate bar. Does that make sense? If you're like a visual learner, you could just draw this whole thing out for yourself. So let's say this is his original chocolate bar, right? He eats half of it, and then he's given a whole another chocolate bar, and then he eats half of that. So he eats, there's 1, 2, 3, 4, 5, 6. So he eats 3 pieces. So in total, he ate 1 and 1/4 chocolate bars. So you can always just draw it out for yourself if you're a visual learner. So again, for whoever's confused, we have originally 1 chocolate bar, right? Let's say the chocolate bar has 4 pieces, just to make our picture easier. He eats half of it, right? So that means he eats these 2 pieces. He still has half left, and his sister gives him another chocolate bar. Now, if we read the question carefully, he doesn't eat half of a chocolate bar each day, each hour. He eats half of any amount of chocolate he has. Now, in this case, he has these 6 pieces of chocolate left. So now he's going to eat half that amount, which is 3 pieces, which means in total, he consumed 1 and 1/4 of a chocolate bar in 2 hours. Does that make sense? Okay, the next one, we have this 3-dimensional shape, which is a cube, and they want us to figure out the angle formed by these 2 diagonals that they're drawing. So if we think about it, the diagonals are diagonals of congruent squares, right? So if we think about AB, for example, it's just this. And then if we think about BC, it's the piece that's going horizontal, and it's another one going like this. And I know that those diagonals have to be congruent. How? Well, a cube by definition has all congruent sides and angles. And obviously all those squares that make up the cube are all equal in area, which means that all the diagonals are equal. So if you can imagine drawing this 3rd diagonal, which would also be equal, right? Because it's another diagonal of an equal square, we form an equilateral triangle. And the reason I know that is because these all have to be congruent because they're all diagonals of congruent squares. So once you recognize that you can draw a equilateral triangle, you then know that all angles in an equilateral triangle have to be equal. And we know that the sum of angles in any triangle is 180. So 180 divided by 3 is 60 degrees. So again, when you look at a question like this, you have to presume that there's some sort of trick or pattern to it. There's no kind of other way for this to possibly make sense. Okay, the next one, number 69, we have a rectangular floor, which they tell us if we draw the picture, they tell us it's 4 feet and 6 inches wide, and then it's 8 feet and 3 inches long. And the question is, how many square yards of floor covering will be necessary to cover the floor of the room? So the difficulty here is that we're dealing with multiple units, right? So we have feet and inches. So the way that I would try to deal with this is try to deal with all one, right? So instead of feet and inches, let's try to convert this whole thing just to feet. So this is easy because we know that 1 foot is 12 inches. So 6 inches is obviously half of 12, so that's half a foot. So I can just convert this to 4.5 feet. And then this is also not bad because 3 goes into 12 4 times. So I can just convert this to 8.25 feet. Right, so we can work with decimals. Alternatively, if you guys wanted to, you could also work with mixed numbers, right? So instead of converting this to 4.5 feet, I can say this is the same thing as 9/2 feet. And on this side, I can say 33/4 feet. So whichever way is more convenient to you, whether it's fraction or decimal, you can work with that. So next thing we want to do is we want to think about what the what the square footage is, right? Because we want to cover the floor, and that's the question about square yards. So first we need to figure out square feet. So let's say I'm going to work with the fractions. So 9/2 times 33/4. This is going to give me 297/8 square feet. Now I have to think, well, how do we now convert this into yards? So now we have to think about conversion, right? So we know that 1 yard is 3 feet, right? That's given, they're telling us. But be careful because now we're dealing with square feet. So we have to square both sides. So 1 square yard is actually 9 square feet. So now what we have to do is convert this into yards. So in order to convert feet to yards, we divide by 9. And it's not an accident that 297 is divisible by 9, right? That's obvious. So here we end up with 33/8 square feet, square yards, excuse me. And then that's just for 4 1/8. The big thing to take away from here is when we're dealing with square feet, you have to change your conversion factor. So 1 yard is equal to 9 square feet, and 1 foot is equal to actually 144 square inches. So it's not something that you have to memorize these conversions. You just have to be aware that whenever you're dealing with conversions and square feet, you square the conversion. Or if you don't want to realize that, you can just memorize these as well. And this is true for any conversion. So if you're converting like centimeters to square meters or whatever it is, that you do the same thing. You square the conversion. Okay, let's keep going. So we have in the last step in solving a problem, Jerry divided by 0.4 instead of multiplying by 0.4 and arrived at 400. So what we'll do is we can work backwards. So he divided by 0.4, right? So he got some number divided by 0.4 equals 400. And I want to figure out what this number is. So I'm going to multiply both sides by 0.4. So if I multiply both sides by 0.4, I end up with x is equal to 160. Now, he wasn't supposed to divide by 0.4. He was supposed to multiply by 0.4. So his actual answer should have been 160 multiplied by 0.4. And that answer is choice A, 64. And then a way to do this quickly would be 160 times 4/10. And then 16 times 4 is easily 64. Another way to do it quickly is realize you're multiplying 0.6 by a fraction, right? So you expect your value to be less than 160. And you expect your value to actually be less than 80 because 80 is half of 160, right? That's 0.5, but 0.4 is smaller. And the only answer that's smaller is A. So again, you have to prove the correct answer to yourself in multiple ways. We can all do this multiplication, but you don't always have to do it this way. Converting to a fraction here makes the arithmetic much faster, and forcing your brain to estimate makes you that much faster and also that much more likely to catch a silly mistake or an arithmetic mistake if you were to make it. Okay, next they say, what fraction of the area of the larger rectangle is the area of the shaded region? So first you recognize that there's 1, 2, 3, 4, 5, 6, 7, 8, right? 8 boxes in here. Then you think to yourself, what can we do then? So some of them are easy, right? So some of them are like whole boxes that are really easy, right? So this is one full box. This is one full box. This is one full box. And this looks like it's perfectly half. So we definitely know that it's greater than 3.5 out of 8. So then what would you do? How do I get an exact answer here? Would you estimate? What are some strategies you guys can think of? So if you just take this, for example, you can see that this is almost half divided, right? So you can think of that. And then you can imagine if we went all the way here, this shaded area is also like almost perfectly half divided. So we're looking at an answer where it's like, let's say it's 4/8, right? That's half. But then we also have this extra full square. So that's about 5/8. But that's pretty dangerous to do here because we have 5/8 and then we have 11/16. 5/8 is 10/16. So that's very, very similar, right? So sometimes you have to look at the answer choices and say, is this a good question for me to guesstimate on? And if you have such a close answer choice, that probably means it's not the best answer to guesstimate on. Because how do I pick between these if I'm just guesstimating? So we've got half of a square here. That's definitely a half, right? Then we've got 1, 2, 3. And then this looks like it's half. So this is one full square, it seems like. So we've got 5, 6, 7 and a half. Or 5, 6, 7 and a half full squares. The answer here is actually B. So you just have to be very, very exact in order to get it. Does that make sense? So again, we've got 1, 2, 3, right? And then this is a half, 3 and a half. And then this one we can see is so 1 squared, 2 squared, 2 squared. We can all agree this is 3 squared. And this is a 4th square, correct? This is a 5th square, correct? So we're already at 5/8, and then we've got this extra piece, which means that it can't be 5/8, and it can't be anything less than that. So we're left with 11 out of 16. Does that make sense? Okay. The main thing that I want you guys to learn out of this question is using the answer choices to figure out when it's okay to guesstimate and when it's not. And noticing that 5/8 and 11/16 are really close and understanding that that's kind of where they're trying to get you. Okay, the next one. How many numbers less than 51 are a product of two different prime numbers? And then they give us some definitions that a prime number, by definition, is only divisible by 1 in itself and no other numbers. And the number 1 is not considered to be a prime number. Okay, so the way that I would think about this is I would try to write out all the prime numbers that are less than 51, right? So the first one that I can think of is 2. The one after that is 3. Then we have 5, we've got 7. And then you have to be careful because they're no longer just like odd numbers. 9 is already divisible by 3. So that we skip 9, the next one is 11, 13, we skip 15 because it's divisible by 5 and 3. 17, 19, we'll skip 21. 23 works. We skip 25, we skip 27. 29 works. Then what else? 31 works. 37 works. And then we can stop there because most likely when we start multiplying, it's going to be greater than 51. So then let's start multiplying. So at first I would multiply 2 by all of it because it's the smallest number, right? I don't want to extend higher than 51. So we can say 2 times 3, 2 times 5, 2 times 7, 2 times 11, 2 times 13, 2 times 17, 2 times 19, 2 times 23, and then this is 46, right? And then 2 times 29, and that's I'm already greater than 51, right? I would be at 58 at this point, so I don't care about anything past that. So here I've got 1, 2, 3, 4, 5, 6, 7, 8 products so far. Then we can try with 3, right? So then we can say, well, 3 times 2, we already counted that one. So we'll do 3 times 5, 3 times 7, 3 times 11, 3 times 13, 39. And then 3 times 17 already doesn't work because that's exactly 51. This is really exact. Less than means not including 51. If they wanted you to include 51, they'd say less than or equal to. So we're not counting this one. The next one, we can try 5. We wouldn't multiply 5 by 2 because we already counted that. We wouldn't do 5 times 3 because we already counted that as well. So the next one we would do is 5 times 7, which is 35. And then the next one, 5 times 11, is already too big, so we don't care about that. And at this point, we're done because everything else is going to be larger. So we had 8 here, we have 4 here, and then we've got 1 here. So altogether, that adds up to 13. And be really careful to follow the instructions. Less than means less than, doesn't mean less than or equal to, and 2 different prime numbers. So that's why we didn't do 2 times 2 or 3 times 3 or 5 times 5, because the parameters of the problem told us they have to be different prime numbers. Okay, any questions? All right, guys, we're almost done. We just have 8 questions left, and we did the whole section. So let's try to finish up. So the next one, we've got a wooden block. They're giving us the measurements, right? 2 by 2 by 3. Then they cut off all these wedges from each corner. How many edges does the resulting solid have? Okay, so we should try to think about what happens to one corner, right? So at each corner, we're going to get 3 edges. Does that make sense? We're going to get 1, 2, 3 at each corner. So now we have to think about it. So then we have to think, well, we get 3 edges at each corner. And in the solid, we've got 1, 2, 3, 4, 5, 6. We don't see this one, but it's there, 7, 8 edges. 7, 8 points, right? Vertices, corners. So edges are the actual sides. So let me see if I have a solid for you guys. So here's my little block, right? You guys can see that. It's like a rectangular prism. So sorry, hold on. Okay, so you guys can now see it, right? So these long sides are called edges, right? Where my finger is pointing it. all the corners, these are called vertices. So we have 1, 2, 3, 4 vertices on this side. And if I flip it over, we have an equal 4 vertices on this side. So any rectangular prism will always have 8 vertices. Does that make sense? It will also have 8 faces. So this is a face, this whole kind of, this area of a square is a face. This is a face, this is a face, this is a face, this is a face. And then we also have this as a face. So each rectangular prism or cube will have 1, 2, 3, 4, and then 5, 6, 7, 8 vertices. And then we have 1, 2, 3, 4, 5, 6 faces. So this is true for any rectangular prism or cube. So rectangular prism / cube will have 8 vertices and 6 faces. And then let's see if we can figure out the edges. So these are edges. We got 1, 2, 3, 4, 5, 6, 7, 8 on the other side. And then 9, 10, 11, 12 edges. So this is just something that you guys can memorize if you're not a good 3D learner and you can't kind of count this visually, but you could also prove it to yourself. If you have any sort of book in front of you or this kind of cube or anything else that's in that shape, you can just count. And then once you visually see it and prove it to yourself, those numbers are easier to memorize. So that's a quick review of vertices, faces, and edges, right? So looking at this cube, right? Basically what they're telling us is at each vertex, they cut a wedge out of it. And from that wedge, we form these 3 edges that we can visualize on the picture. So we have 8 vertices. At each one, there's going to be 3 edges, right? So now we've got 24 edges. But be careful because those aren't the only ones, right? We also have to think about the ones that connect. So these extra 4, 1, 2, 3, 4 that I just showed you guys, we also have to count. So we have to count those 4 extra and we get the answer of 28. So basically you should know that in a regular rectangular prism, there's 8 vertices. In this one, they're making an extra thing by cutting these wedges. And when we cut off the wedge, we get 3 instead of 1. So we multiply this by 3, we get 24. But then we also have these 4. And that's how you get a total of 28. Okay, now the next one, we've got these 2 cars, M left town Q and left town P at the same time. At noon, car M traveled 2/3 of the distance from Q to P. So if we try to visualize what that means, from Q to P, they traveled 2/3. And then this car from P to N traveled 3/4. What fraction of the distance between the 2 towns is the distance between the 2 cars at noon? Okay, so they're mentioning these numbers, right? 2/3 and 3/4, but they're not giving me anything about the actual number of miles that the car traveled. So what that means to me is I can pretend, right? I can create a number of the amount of miles town P and town Q are apart, right? So I want to pick a number that's convenient for me. So what do I mean by that? If I'm dealing with 3/4 and 2/3, what's a good number to pick? Yeah, excellent. 12, right? Because that's going to be my least common denominator of the 2 fractions. It's going to make it easier for me to work with. So I'm going to say that between towns P and Q is 12 miles, right? I'm going to pick that number. So then now I can start putting in numbers. If this first car M, traveled 2/3 of the way from Q to P, that means 2/3 of 12 is how much? That's 8 miles, right? So I can say it traveled 8 miles. We'll do the same thing here, 3/4 of 12. Let's say this car traveled 9 miles. Okay, so we can do that. Now, the next thing, to make it easier, let's call this mile 0. Let's call this mile 12, right? So from P to Q is 12 miles. Now, if car M is 2/3 of the way, that means that it's going to be at mile 4, right? Technically, if I'm creating this number line. So it's going to be at mile 4. And then what about car N? Car N is going to be at mile 9. And then the difference between them is going to be 5 miles, right? So the difference between them is 5 miles when the towns are 12 miles apart. So that means that the distance between them is 5 out of 12. Does that make sense? So basically, because the question didn't give me any numbers, right? I picked the number 12. So let's pretend that here's town P, here's town Q, and let's say that they're 12 miles apart. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Let's pretend these are equal boxes of 12 miles, right? Now, the next thing they told me is that at noon, car M left town Q from here and traveled 2/3 of the distance, right? So 2/3 of 12 boxes or miles, whatever you want to call it, that's 8. That means that car M traveled 1 box, 2 box, 3 box, 4, 5, 6, 7, 8, right? So car M is here at box 8. Does that make sense? Now, car N traveled 3/4 from P to Q. So again, 3/4 of 12, that's 9 boxes. So car N traveled 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And it's here. So the distance between them is 1, 2, 3, 4, 5 out of 12. Does that make sense? So the takeaway for you guys here is when you get a word problem like this and it's just fractions, but they don't actually give you any substance, that tells you that you get to guess a number. The question is pushing you to do that, right? There's no other way to solve it. And when you get to choose a number, you get to pick a number that makes sense to you, which is 12 in this case, or any multiple of that. 24 would have worked fine too. And then if you want to visualize it, you can always draw it out for yourself in this way. Okay, the next one, they tell me that the dashed horizontal line is 12 inches. So from P to Q is 12 inches is what they tell me. And then they constructed 7 squares as shown in the diagram, 4 above and 3 below. Okay, that makes sense. So 1, 2, 3, 4, 5, 6, 7. Okay. And then they want to know what is the length in inches of the continuous path from P to Q? Okay, well, how can we figure this out? So first of all, we know that this is 12, right? And we know that it's continuous, right? So like we know that it's a square. So what I would do is I would pick values, right? So I know that there's 7 squares, and I know that they need to add up to 12, right? Because they told me that this horizontal line is 12 inches. So I'm gonna pick the length of one side of the square, right? So let's say that I think this is 3 inches, this will be 1 inches, this one looks smaller, so I'm gonna call it 2 inches. And then 2 inches, 3, 4, 5, 6, 7, 8. Let's say another 2 inches, 10, and then let's say this has to be 1 and 1, right? For it to add up to 12. Now it's obviously not drawn to scale, but it doesn't matter. Because in total, the sum has to all add up to 12. Does that make sense? And the scale is going to be weird and off, but remember that the drawings don't matter. They're not drawn to scale. And you have to realize that each of the sides are equal, right? So now we will say, well, this is 3 by 3 by 3. And then this is 1 by 1 by 1, and this is 2 by 2 by 2, and this is 2 by 2 by 2, and 2 by 2 by 2, and 1, 1, 1, 1, 1, 1, and then we have to add that all up. So 3, 6, 9. 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 22, 24, 26, 28, 30, 31, 32, 33, 34, 35, 36 in total. Okay, the next one, we've got 4 congruent rectangles placed around the square to form a larger square. The perimeter of each rectangle is 20. Okay, so if the perimeter is 20, what can the sides be, right? So the perimeter means that I have x and y. So I've got 2y plus 2x is equal to 20. So to make it easy, let's say that this is, let's say 1, and this is 9. Which means that here is 9, here is 1, 9, and 1, and 9, and 1. So what that means is that the square ends up being a 10 by 10 square, which is 100, which makes the area 100. Does that make sense? Okay, if we keep going, we've got black marbles along the circle with a circumference of 72 yards. So you guys need to know your circumference formula. What's the formula for circumference? So you should know that circumference is 2 times pi times radius, good, which is the same thing as pi times diameter. Okay, so we know that the circumference is 72 yards, and they placed some black marbles 3 yards apart. And then his friend showed up and put white marbles so that there is 1 marble between any 2 black. Okay, and then the question is, what is the total number of marbles placed along the circumference of the circle? Okay, so first, the circumference is 72, right? And we're placing 1 every 3 yards. So the first thing that I would do is I would say, well, 72 divided by 3, and what's that going to give me? Okay, so that gives me 24, right? So 24 black marbles. So automatically, I know that I'm going to have 24 black marbles. Now, for every black marble that I place, I also place 1 white marble in the middle, right? So if you think about it, we're putting white marbles in the middle of 2 black marbles. So what you can think about is if you just have 2 black marbles in a circle, we're going to add 2 more white marbles. Does that make sense? If we get 3 black marbles, we add 3 more white marbles, and so on and so forth. So if you imagine a circle, right, and we only have 2 black marbles, I've got to put a white marble in between on this side and on this side. So for the ratio is 2 to 2 is what I'm saying, right? Now the next one, let's say I have 1, 2, 3 purple marbles, then I put pink ones in between, that's 3 more. And that keeps happening. So if I have 24 black marbles, basically what I'm trying to show you guys is we would also end up with 24 white marbles. And our answer ends up being 48. So again, the key here is just to recognize the pattern. Okay, the next one, we have a soap bar in the shape of a rectangular prism with the following dimensions. Each day the soap was used until the 7th day where it had these dimensions. And the question is, how many days could the soap be used in the same amount per day as during the first 7 days? So first we have to get the volume of each and figure out how much of the soap was used per day, right? So the first thing that I would do is I would say, well, 2 times 3 times 1/2. The volume here is going to be 3 inches cubed, right, of soap. And then the volume here, we have 1 times 1/4, which is just 1/4, times 1/2, so times 3/2. That's going to be 3/8 inches cubed. So now the question is, well, how much was used, right? So 3 minus 3/8 is going to give me how much? 2 and 5/8, right?
Olga, let this be the last question, and then we're gonna start saying thank you to Olga, and we're gonna see my cute little doggy. All right, because this will be the last big question we do. Okay, go ahead.
Sure. So 3 minus 3/8, that's what we were up to. So we can make this common denominator to make it easy for us. So we can do 24 out of 8 minus 3/8, and we're going to get 21/8. So we've used 21/8 cubic inches of soap. But the question is, well, how many per day, right? It's been 7 days. So if I want to find out how many per day, I'm going to now divide this by 7. And you guys should know that when we divide, it's the same thing as multiplying by the reciprocal, right? So 21/8 is the same thing as 1 times 1/7. Now this simplifies. So now we can say, well, 3/8 per day. That's how much we used. And we only have got 3/8 left. So that means we only have enough soap for one more day. Okay. So that marks the end of our math webinar. We basically completed the entire section. So you guys now have a fully annotated copy. And I'll send out the notes to Ms. Francis, so you guys will have these. And it's been a pleasure. Hopefully we can see little Munchkin again and close out the night. I hope you guys had,
Olga is providing a recap. Is that your recap now? No,
yeah.
we're good. That's kind of the recap. Everyone who wants to see a cute doggy. Hold on, start video. Wait, I have to turn the lights. Hold on, I'll be back. 1 second, guys. Hold on. 1 moment. Goldie, come here. Come. Okay, ready?
We are ready.
Okay, ready? Hi, guys. Cushy, cushy, coo. Who wants to see the doggy? Did the dog learn something? Say thank you, Olga. Look at this doggy. Are you guys in love? Look at this. Look at this face. Look at this face. Olga, can you take a screenshot? Because I can only do so much at once. No, don't yawn in my screenshot. Olga, send me. Can you send me some of the chat thank yous also? Because I'm on the computer. Olga is taking some screenshots for all of us, as our dog is now the center of the Zoom attention. Oh my God, this dog is totally asleep. Do you live the dream? Yes, this dog is living the dream. Look at this face. I have a surprise for all of you. We have more than one dog. Who wants to see a second dog? Ready? Olga, you're taking screenshots, right? Promise? Who wants to see a second dog? Ready? Are you guys ready? Ready? Hold on. Goldie, come here. We want to see you. Wait, I'm getting a second dog. Okay, you're all gonna be in for a big surprise. Ready? We have a second dog. Whooshu! Look at this face. Look at that face. Goldie! This dog is 13. Goldie, we call this Grandma Goldie. This is Grandma Goldie Kweller Prep. 13 years old. This dog used to have gold hair, not white. Okay? Goldie. There, guys. Do you love it? Yes? Ready? Who wants to see the baby? The baby. Ready? This is the baby. This is the new baby. Look at the baby. I feel like the dog enhances the whole webinar. I mean, Olga, you're amazing also, but I feel like the dog really brings it home. Oh my gosh, this is so, oh, you're taking screenshots. I love you guys. Check it out. Look at this dog. Wait, let me like put the dog by the diploma. Okay, there we go. Look. Yay, look at that face. Look at the face of the doggy. Push, push. The dog looks very. Okay, ready? Say good luck in the hunter test. Good luck on the hunter test. Good luck on the hunter test. Coochie, coochie. Thanks, guys. Connor, you're the best. All right, everyone. Who wants to say thank you? Who wants to go off mute and say thank you? Ready? Are you guys ready to say thank you to Olga? Kushiku. Olga, can you take we're gonna count, we're gonna go off mute. Are you ready? Ready? Olga, can you unmute everyone? We're gonna count to 3. Olga's gonna unmute you. Ready? Ready? Ready, everybody? Ready? 1, 2, 3. Thank you all.
Two.
Thank you so much.
Thank you.
Thank
We learned
you.
so much.
Thank you.
We learned. We got smarter, better, wiser. Good. Thank you, Olga. Thank you for your colorful notes. Thank you for this academic moment we're having. Which dog is cuter? First one, second one? Look at this little baby. Look at this is Munchkin. Wow, Munchkin, you're really tired. All right, Olga, thank you. Thank you so much for doing this. Thank you, everyone. I'm so happy we had a good webinar. Olga, oh my God, these photos are so cute. Wait, send it to me. Send me. I can't. Oh my God. Munchkin, you are the cutest little Zoom dog in the whole wide world. Do you believe 10 weeks old and this dog is already in an academic tutoring Zoom? Do you believe it? Who would have thought? Right?
Cool.
All right. All my love, guys. Enjoy, okay?
Bye, guys. Good night. Thank you.
Oh, Munchkin, check it out. Olga, you sent me pictures. We got it. All right. Bye. Oh, this is so cute. Bye, everybody. Thank you, everyone. Bye, everybody. Enjoy.
I think Olga's getting that.
Look at this cute. Oh my God, these photos are so cute. I'm saving them. Oh my God, Connor, you're like A+ right now. I can't. Goldie, you look so good. Goldie, I'm saving you. Doesn't Goldie look so good for 13? I mean, not a day over 5. Look at that face. Look at that face. Look at that face. I'm in love. I'm in love. I'm in love. Everyone, you guys are the highlight of my evening. I love these moments. I just want to share with you what an amazing experience it is to have all of you in the Zoom. Oh my gosh, this is so cool. Guys, this is the funnest Zoom ever. It's called Meet the Dogs at Kweller Prep. This is so funny. Thank you, everyone. Thank you. Thank you for a very good experience. Oh my gosh, Kara, Sony, I love Kweller Prep. Look at that. We love you too. Thank you. Thank you for a wonderful evening, everyone. Have a very good night. Thank you. Thank you. Thank you. Bye, everyone. Yay. Oh my gosh, look at all these comments. You guys are the best, okay? Thank you, guys. Bye, everyone. Have a good evening. Thank you. Thank you, thank you, thank you. Bye, everyone. Bye, everybody. Bye.